So, dear student, in the last class, we have started the chemical properties of haloalkanes. So, in that regard, we saw reaction with sodium hydroxide, potassium hydroxide, and then later, very important, that is with the KCl and with the silver nitrate. Silver cyanide. So, these reactions are very easy. And in case of AgCN, you just aware of that. That is because of presence of covalent bond in that. That's why it will not give a cyanide form. It will give a isocyanide form. So in the last class only I have shown you, and actually I have explained very briefly about AgCN. Why that will break as a NC, not as a CN, right? So there was a one doubt from one of the student, right? So he was asking about, so if halogen is attached to sp2 hybridized carbon atom, means what should we call that particular example as? But directly I can say Mallappa has asked this doubt, but I don't think that the Mallappa is following my classes, right? Why? Because if the sp2, say for example, anything is possible, right? That can directly attach it to sp2, right? I have shown directly, right? ch2 double bond chbr, right? Definitely it might attack. It might be attack like this. One, two, three, four. Two, three. I mean, double bond after double bonded carbon, right? It is possible that, but we won't consider that as a haloalkane, right? For different examples, I have given you in the classification only. Please, you go through allylic, benzylic, vinylic, right? These are the four types. You go through that. Definitely, you will be having your doubt with full 100% conclusion, right? So, see, if I change a one hydrogen atom from the alkane, then definitely we won't call that as an alkane itself, right? So, if I remove one hydrogen, then definitely what we call that as? We call that as an alkyl group. Then how we call halogen is directly attached to the carbon. That means sp2 hybridized carbon means we have different category, right? Zem dihalide, Vic dihalide, vicinal, geminal, allylic, benzylic, vinylic, right? So these are the different categories, dear student. You go through that. Why? Because these are very important, and in our main examination, definitely where there will be a little bit twist, not more twist, in that part only you will be having, or you will get definitely one question, right? So you go through that Malapad, definitely you will get. In the second class itself, I have explained. I think second or third, I don't know. You please check the videos and have your doubt clear. Why? Because I don't want to explain again. Why? Because see, if I explain again and again the same thing, then definitely who is following me correctly, for them it will be just like a what time pass class, right? So I don't want that, right? So your doubts are always welcome. Please follow. If you are not getting, then do ask. We don't have any problem, right? So next is reaction with reaction with silver acetate. Names are very very important, right? So 90% organic chemistry is based on names. If you don't know the naming, then definitely organic chemistry will look very very typical, right? Or it will be very difficult. So silver acetate means the formula is you just add remove hydrogen from acetic acid and add silver, I mean Ag, that becomes silver acetate, right? So now what we will do, we will make this silver acetate to react with what? Alkyl halide. If I make this to react with alkyl halide, then what happens? See, CH3COO, sorry, CH3COO So there is no presence or nothing. So now what happens is definitely see here this reaction is very easy. So always Ag will be in the form of what? Plus positive charge, and this part will get negative charge. Why? Because oxygen. And what about this? This will be positive and this will be negative. Never this part will go and attack this. Why? Because they are having same charge. That means they repel. Definitely this will go and attack over here, and likewise what we will get, see CH3 COO R, right? I mean ester, and then Ag will go with what? X. It means AgX. Here we will get a ester from COO C, I think, or RCOOR, RCOOR, right? So such examples. That means whenever the alkyl halide reacts with the silver acetate, then definitely the formation of ester takes place, right? So this is the very simplest reaction one I can say. And the next is reaction with, that means the next reaction will be action with silver nitrate. Action with AgNO2, we can say silver nitrate. So if alkyl halide reacts with silver nitrate, then definitely what we will get? We will see. Just we will check it out. Alkyl halide reacts with AgNO2. So definitely again, what is the condition over here? Ag is positively charged species, NO2 is negatively charged species, and then definitely what about these two? The same case, right? So now what we will get? I mean R NO2, right? Plus byproduct is again AgX, right? So likewise, if you see the reactions of alkyl halide, these are very simplest reaction. And one more, that means reaction, I mean action with, one more example, I mean one more reaction, action with lithium aluminum hydride. And this is the strongest reducing agent one we can say, right? Remember this, whenever we use this, definitely addition of hydrogen takes place, right? So now the case is over here is little bit different, right? So definitely this part will be positive and this will be negative, partially negative one, and then this will be again partially negative. Whenever lithium and aluminum are two metals, right? So because they are showing, that means aluminum is a big molecule, I mean metal. So that's why what it will do is this lithium and hydrogen will not get negative charge directly. Because of aluminum, what happens? It is a metal means always they donate the electron, that means they prefer to lose the electrons. So that's why what happens, partially negative charge will come onto what? Lithium as well as the hydrogen partial. So now what happens is, whenever I make this alkyl halide to react with lithium aluminum hydride, then see here, very important part. So that means, see, definitely this hydrogen will go and attack. Why? Because see, still kinetics chapter is not at over. So that's why just remember, whenever the same charged species are more than one in a single reaction, then what happens? Overlapping, there only we will get the some difficulty in the chemistry, right? So this you need to understand. So now what happens is, see, here we have only two species, I mean alkyl and halide, I mean halogen and alkyl group. So what happens? Definitely they break. They break means what happens? It will be having negative charge and they break in such a way that it will get, I mean alkyl group will get what? Positive charge. So thus what happens? Lithium again a metal, aluminium is also a metal, but in complete compound, hydrogen is having what? This is very important reaction, right? So hydrogen is having partial negative charge. So that's what happens in the first step. R will, I mean H will go with R, right? And now after removing this, what happens? Again, the electron density is more on what? Aluminium, I mean lithium. So lithium will get again negative charge only. So thus, what happens? Hydrogen is removed over here. I mean, from lithium aluminum hydride, hydrogen is completely removed. And now, what is the next is X, and X is always a negative charge, right? And aluminium is a more positively charged species. So now, what happens is aluminium will go with X, right? And now, what is left? I mean, lithium is left. So lithium is left. Now, after removing aluminum and hydrogen from these, definitely aluminium will get positive charge because of I mean lithium get positive charge because of aluminum only. It was showing a partially negative charge. After removing these two, definitely it will show positive charge. It will show positive charge means the negatively charged species from the other reagent is only X. So thus it will again react with X. So now we want to, I mean, balance this equation, right? So hydrogen is not yet balanced. So thus, how many number of hydrogens are there? 4. So simply you write 4 over here, right? And then now R is imbalanced. So balance R, just you write 4, right? Why? Because I'm just what balancing the main compounds, right? So R is balanced. Now what about X? X is not yet balanced. So now aluminium, see here again, aluminium will get positive. I mean always the aluminium oxidation state is +3. So thus X will show only one negative charge. So that means how many X we require for one aluminium? 3 X. So therefore Al X3 aluminium halide, right? So this is the reaction which was very important, right? And here there is no twist, right? There is no twist, but little bit understanding thing. I mean, we need to understand the what happens when more than same charged species are present in a same reaction. So there we will get some difficulty. So that's why before going for such reactions, we completely should know about the reagents. Once if you know the reagents and their activity, then definitely the reaction will be very easy. And student, organic reactions are very simple. If you remember their charge, their electronegativity, that's all. This is the thing. These 2 to 3 things are very important. If you remember these things clearly, then organic reactions are very important, very easy reactions as compared to the inorganic reactions. In inorganic reactions, we need to balance the equations. So that is the most difficult case. And in inorganic reactions, the same charged species may be present in more than 2 or 3, sometimes 3 one we say, right? In the preparation of K2Cr2O7, we saw the reaction, right? So but here there is no such case, right? So now I will take you to the very important part of this chapter is SN1 and SN2 reactions. And among SN1 and SN2, compulsory one reaction will be there in your, should be there in your examination. In the last year, they have asked about SN1 reaction, right, and their mechanism. Here, today, we will just see the introduction of this, right? What is SN1 and all, right? So SN1 reaction. So SN1 reaction is nothing but, see, unimolecular, right? The name of this is unimolecular nucleophilic, yes means substitution reaction. Unimolecular nucleophilic substitution reaction. Substitution reaction. So here, see, during chemical properties explanation, I said they undergo nucleophilic elimination as well as the substitution reaction. So substitution is nothing but very important. We will not add completely, right? So we just replace one group from other group, right? So we will see in detail. You don't worry about this, but unimolecular nucleophilic substitution reaction. So unimolecular means here it is a first order kinetics. I mean, in chemical kinetics, I will explain these terms. And I mean, later, nucleophilic means negatively charged species will be substituted in the reaction, right? Very simple. Nucleophile means negative charged species. Negative charged species will be substituted, right, in the reaction. Substitution, not addition. Addition is totally different from the substitution. In substitution, we just replace. Say for example, in the halogen replacing Schwartz reaction, Finkelstein reaction we saw, right? So there, what we were did, we just replaced chlorine with bromine or bromine with chlorine, right? Right, by using AgCl or in the Schwartz reaction. In the same way, completely removal will not be there or completely addition will not be there in substitution reactions. So we just substitute one element or a group or an atom with the other element, group or an atom, right? So that is nothing but the nucleophilic substitution reaction, right? So dear student, it requires a complete class for me, right? One complete class. So that's why what I thought, in the tomorrow's class itself, I will explain. Please do follow these classes. Why? Because these are very, very important. If you after explaining also in the online classes, if you are not getting, then definitely definitely we will explain again, right? You don't worry about that. But the complete chapter, it not be possible. It might not be possible, or we won't get such interest. Why? Because already I have explained in the online class means it will, 25% interest will be gone. Why? Because some of the student may follow completely, some of the student may not follow. Who the student who had followed completely, for them, if we explain again, then it will be waste of their time, right? So I don't want that. Please do follow. Definitely, I know some of the concept will not be clear. Why? Because in the offline classes, what we will do directly, you can ask the doubts. But here, the such conditions are not there. So that's why if you just listen these classes, then enough. Why? Because after listening class, you will do something. I know that, right? So that's why please do follow. Right? Thank you.